Good morning, guys. Good morning. Good morning. Welcome to the lesson number 5 of the class. Today we're going to see a new topic, and it's important to pay attention. And today we have different information of the lesson 5. The lesson 5 talk about one of the most important topics for science in chemics, and the name is the periodic table of the elements, right? An elegant arrangement, right? What is the periodic table, right? Such as an important tool, right? Okay, good morning, good morning. We're going to continue. In the 18th, Dmitry Mendeleev, right? Mendeleev was searching for a better way to list the elements. So you know that we have a lot of elements in the planet, right? And the periodic table, right, is an important tool. We're going to see what is a periodic table and what this table contains, right? We are not going to see all the elements because it's a lot of information. Just we're going to understand today the objective of the class is to understand what is the periodic element, who invents the periodic element, and what for is. So Dmitry Mendeleev was searching for a better way. He invents the periodic element to list the elements in a logical order. He looked at their physical and chemical properties and soon realized that they could be arranged neatly into a chart. The periodic table of the elements used today by chemists everywhere is based on Mendeleev's work. Okay, in conclusion of this reading, we are going to define, or we can define, that the periodic element table was created in the 18th by Dmitry Mendeleev, right? He did it. So the elements are placed into the table in order of their atomic numbers. Okay, the atomic numbers and elements' atomic numbers tell how many protons are inside each of us, its atoms. How many protons, right? The periodic table also divides the elements into rows and columns based on the numbers of shells. Pay attention in this part. Again, the periodic table also divides the elements into rows and columns based on the number of shells the element has. The electrons moving around an atom's nucleus don't share the same orbit. They are divided into orbitals or shells. Think of them, you're going to define this word in the notebook. What does mean shells? Think of them like layers in an onion, right? Each shell can hold only, pay attention, each shell can hold only a certain number of electrons. The inner shell holds just 2, but the next shell can hold as many as 8 electrons. The third shell can hold 18 electrons, and the fourth can hold 32. Again, pay attention to this part. This is the answer of some questions in the classwork. Each shell can hold only a certain number of electrons. The inner shells holds just 2, the inner, but the next shell can hold as many as 8. Okay, the inner 2, the second or the next 8 electrons, right? And the third shell can hold 18 what? 18 electrons. And the fourth, 32. Helium, for example, is a name of one element. For example, has 2 electrons. It needs just 1 shell. Oxygen, for example, is other element, has 8 electrons. Its inner shell holds 2, and its outer shell holds the other 6. The outer shell is not full. Through, remember, it can hold up the 8 electrons. It's only one example. This reading is only giving you an example. This is the picture of Mendeleev, right? The one that invented the periodic table. And we have the famous periodic table of the elements. In high school, chicos, in high school, cuando ustedes lleguen al colegio, in high school, you're going to study this table in each element, and you're going to make formulas of each one, right? Today, you're going to see this topic in science in just what is and what contains, right? So to finish this part, I'm going to tell you this is our example when it's the same periodic table of the elements, right? Each row of the periodic table tells how many shells. I already read this. Each column of the periodic table tells how many electrons are in the atoms. Pay attention. I didn't read this part. I'm going to read it again. Each row of the periodic table, right? Column, row, column, row, right? Each row of the periodic table tells how many shells an atom needs to hold its electrons. Aluminium, for example, with atomic number 13, is in the third row, right? In the third row, right? It needs 3 shells or orbiting electrons to fill the inner shell. 8 fills the next shell, and 3 electrons orbit in the outer shell. Okay, it's only the theory. Esto es solo la teoría. Each column, right, of the periodic table tells how many electrons are in an atom. Atoms out of shell. Atoms in the first column have just 1 electron in their outer shells. Atoms in the 5th column have 5 electrons in their outer shells. And to conclude, to meet the conclusion of the reading, atoms try to fill their shells with electrons. This is why molecules form the chemical reactions. And how the chemical reactions happen. Atoms combine with other atoms so they can share electrons and fill their I don't see the last part. So we are going to make the classwork super easy. The periodic table does not tell you, Option A, each element's atomic number. Option B, which family and elements belong to. Option C, the temperature of which an element which melt. And how many electrons are in each kind of atoms. How many electrons are in each kind of atoms? I don't know, shoes. I think you're going to define you can investigate in internet if you have a question, right? I think each element's atomic number, which family and elements belong to, and the temperature at which an element will melt, right? How many electrons are in each kind of atoms. This information is there, right? I think this information is not there, right? This information is in here. The family, I think, is the family an element belong to. I think this is the information, right? The number of electrons in an atom's outer shell determines which, again, the number of electrons, this is very easy. The number of electrons in an atom's outer shell determines which what? Column, family, row, or table? It's in. The number of electrons in an atom's outer shell determines. Is in the theory, super easy. Write your answer on the lines below. How many electrons can each shell of an atom hold? Shell closest to the nucleus. Second shell away from nucleus. Right? Sorry. And the last one, I move it. Sorry. The third shell away from the nucleus. This information is in the reading. The inner, the next, and the third. The inner is the one that is closest to the nucleus. The second shell away from the nucleus, and the third shell away from the nucleus. Okay? Super easy. If you don't understand, let's go to the reading again. I'm going to read the last question, and we are going to go to the reading to define. What is the first element? What is the first element that needs a third shell? What is the first element that needs a third shell? The last one, you're not going to do it. The last one. Let's go to the reading again. And we're going to determine the information. Look, atoms try to fill their shells with electrons with electrons. This is why molecules form a chemical reaction. Pay attention. Each column of the periodic table tells how many electrons are in the atom's outer shell. Let's read the question. The number of electrons in an atom's outer shells determines which column, family, row, or table. Each column of the periodic table, column, you are going to read, everything is in here, ¿ok? Tienen que pensar un poquito. Vamos a definir esos resultados en la clase, en vivo, ¿ok? So, everything is in here. The elements are placed into the table in order of their atomic numbers. Look at this question. For example, the question number 1, the periodic table does not tell you. What does not tell you the periodic table? Let's see what's not going to tell you. Let's go to see. Okay. Let's see. The internet is magic, so we're going to follow the investigation. The periodic table is not going to tell you. Wait, the question is not going. I want to make what is not going to tell you the periodic table. What is not going to tell you the periodic table? We have some videos. Okay, you may remember the periodic table of the elements as a clearly chart of your beyond the edge atoms with atomic numbers higher. What? Well, you're going to read them. Not only that is grown, new elements have been discovered. No, this is not correct. If you tell me an element is a certain place, so I think the answer is this one. What is not going to tell you the table? Let's see. This is our answer. Look, each row of the periodic tables tells how many shells and atoms need to hold in electrons. Right? This is an example. So we know that each row tell me the atoms, the electrons. I know that it's going to tell me this. So maybe here, right? The elements are placed into a table, obviously, right? Their atomic number. We know it's going to tell me the atomic number. An element's atomic numbers tells how many protons too, are inside of each atom. The periodic table also divides the elements into rows and columns based on the numbers of shells that element has. Very good. Dmitry Mendeleev searching for a better way to list the elements in a logical order. He looked for their physical and chemical properties who realized could arrange nearly into a chart the periodic table of the elements used today by chemists everywhere in base of Mendeleev's work. Mendeleev's it was important investigation, right? So I think the answer of this, so maybe can complicate, it's not going to tell you maybe which family and elements belongs to. I think this is the answer, right? This is very complicated thing. Okay, and this one is super easy. This one super easy. You have it in here. You have it in here. Here. You're going to read. Okay, so time is over. Bye bye. See you in the next class. In the next class, we're going to define. Okay. This is the lesson 5. The last lesson. The next lesson, you're not going to have classwork on in here. Love you. Bye bye.